Today, we're going inside the most ambitious, most incredible scientific experiment ever attempted by humankind.
You guessed it, it's the Large Hadron Collider, and we're about to explore this amazing machine, a machine built to answer the absolute biggest questions about, well, everything.
So what exactly is this colossal machine? I mean, to really get it, you first have to wrap your head around its sheer, mind-boggling scale.
Okay, first, picture a circular tunnel that's 27 kilometers long. That's big enough to wrap around an entire city. This isn't a subway, though. This is a racetrack for the tiniest particles in the universe. And this whole thing, it's buried 100 meters, that's about 30 stories deep underground, right on the border between France and Switzerland. It's all part of CERN, the European Organization for Nuclear Research.
Now, this is just wild. To steer those particles, thousands of super-powerful magnets have to be chilled to minus 271.3 degrees Celsius. That is literally colder than the empty void of deep space. They've created one of the coldest spots in the entire universe, right here on Earth.
And why go to all this trouble? Well, the mission is pretty simple to say, but unbelievably hard to do. They take two beams of protons, accelerate them in opposite directions to almost the speed of light, and then smash them into each other. Every single one of those collisions is like a tiny fireball, recreating the exact conditions that existed just moments after the Big Bang.
So, how in the world do they actually pull this off? Let's break down the whole process. It's really a four-step journey.
Believe it or not, it all starts with a simple bottle of hydrogen gas. Protons get stripped from the hydrogen atoms, and then they're shot into a series of smaller accelerators to get them going. Then, the main ring superconducting magnets take over, pushing them to 99.99999% of light speed. And finally, bam! The two beams are steered right into each other inside these enormous cathedral-sized detectors that record every single thing that happens.
Just to give you an idea of how precise this is, yeah, it's like firing two needles from 10 kilometers away and having them hit each other perfectly in the middle. The level of engineering here is it's absolutely extraordinary.
Now, the most famous particle to ever pop out of these collisions is, of course, the Higgs boson. When they found it back in 2012, it was a massive deal. See, the Higgs is tied to this energy field that fills the entire universe, and without it, nothing would have mass. No atoms, no planets, no stars, no us. Finding it was a huge Nobel Prize-winning achievement.
But finding the Higgs wasn't the end of the story, not even close. In fact, that discovery just blew the doors open to a whole new set of questions that physicists are now desperate to answer.
And we're talking about the biggest puzzles in all of science. Like, what is this invisible dark matter that seems to be holding entire galaxies together? Why are we here, made of matter, when the Big Bang should have created equal amounts of matter and its opposite, antimatter? Are there, other dimensions of reality we just can't see? The LHC is on the hunt for clues to all of these cosmic riddles.
One of the leading ideas that could answer some of these huge questions is a theory called supersymmetry. You might hear physicists call it SUSY. It's a really beautiful concept that they're hoping the LHC will finally prove or disprove. So the basic idea behind SUSY is that every single particle we know and love has a hidden, heavier superpartner. So your friendly neighborhood electron would have a partner, a photon would have a partner, and so on. If we could find these particles, they might just be the solution to that whole dark matter mystery.
Now, you might have heard some rumors that the LHC has already ruled out supersymmetry, but that's not really the whole story. As you can see here, while some of the simplest versions of the theory have been challenged, there are still plenty of ways it could be true. The hunt is absolutely still on. Okay, so this brings us to a few popular myths about the LHC that we need to clear up, and then we'll take a look at what's next for this incredible machine.
So there's this persistent fear you see online that the LHC could create a black hole that swallows the Earth. Let's be really clear. No, it can't. And here's why. Nature itself is doing the same experiment, but way bigger all the time. Cosmic rays, particles from space, smash into our atmosphere constantly with energies that make the LHC look tiny. And, we're all still here.
So what's next? Well, the future of the LHC is all about getting more data. A huge upgrade is in the works called the High Luminosity LHC. The whole point is to dramatically crank up the number of collisions, because more collisions means a much better shot at spotting something brand new and incredibly rare.
And here's the game plan. They're going to be installing powerful new magnets and a bunch of other cool hardware over the next few years. The goal is to fire up this new, supercharged version of the LHC around mid-2030 and keep it running all the way into the 2040s.
And get this, even while they're working on that upgrade, scientists are already dreaming bigger. They're planning a next-generation machine, a future circular collider that would be 100 kilometers around, nearly 4 times bigger than the LHC. Just imagine the secrets a machine like that could unlock.
So when you step back and look at the big picture, what is the LHC all about? What is its lasting impact going to be?
Well, it's so much more than just a particle accelerator. It's like a time machine that lets us see the birth of our own universe. And it's a cosmic microscope that lets us stare right at the fabric of reality itself. It is, without a doubt, the greatest tool for discovery we have ever built.
What we found so far has been amazing, but the universe is still just packed with mysteries. Honestly, in a lot of ways, the Large Hadron Collider is just getting warmed up. The only real question left is, what secrets will it reveal next?